This is the video for the test 2 review, questions 11 through 15. Question 11 says, below is the graph of a polynomial function. So you'll see that graph on Alex, or a graph similar to it. All local extrema of the function are shown in the graph. So they've put little like X's wherever the extrema are for the picture. Use the graph to answer the following questions. Over which intervals is the function decreasing? So decreasing means as you are reading from left to right that you're going down. So I'm going down here, which is negative infinity to negative 7. So they use the x coordinate to write that interval. Notice that it's always going to have parentheses for increasing and decreasing. And the reason is that I can't say exactly at that point, negative 7, whether it's increasing or decreasing, because you come in and then you go up. So what's happening exactly at that point, we don't really know how to say what's happening there, so we do not use brackets. Okay, where else is it decreasing? From here to here, right? What are the x values? Negative 3 to 2, so there's a decreasing. And then finally from here to here, what are the x values? 5 to infinity. So those are the three decreasing. It says at which x values does the function have local minima? So I've labeled all the local extrema. The two minima are right there. And so the x values would be negative 7 and 2. So negative 7 and 2, they want us to put a comma. Those are both x values, so we don't put them in parentheses together because it's not an x and a y, it's two x's. Okay, C, what is the sign of the function's leading coefficient? Well, it's generally going down like a negative slope, so the leading coefficient must have been negative. And then finally, which of the following is a possibility for the degree of the function? So the way that we do this is we count up the number of extrema, and up here they said all of the extrema are shown on the picture. So I have 1, 2, 3, 4. If I have 4 extrema, then the smallest degree my function could be would be 1 more than 4, which in this case is 5. So it could be 5. Because it's odd, I know it's odd because the tails are going in the opposite direction, then it could only be odd numbers bigger than 5. So it could be 5, 7, or 9. And so it could not be 3 because I have 4 extrema. It has to be at least 1 more than the number of extrema we have. Okay, question 12. Says use synthetic division to find the quotient and the remainder when negative 2x to the 4th plus 9x to the 3rd plus 5x squared minus 4x plus 20 is divided by x minus 5. And so with synthetic division, what we do is we divide the 0, so if I'm dividing by x minus 5, then the 0 would be 5, because I would set that equal to 0 and solve it. So the 5 goes into these coefficients. So you want to make sure that it doesn't miss one. So I've got x to the 4, 3, 2, 1, 0, so they're all there. So I would put negative 2, 9, 5, negative 4, 20. And the way that this goes is that and I know I draw mine upside down. For synthetic division, a lot of books do it that way, and I like it better than doing it right side up because it gives me this nice bar here. So anyway, I bring down that first digit there, which is a negative 2, and then I multiply 5 times negative 2 is negative 10, and then I add this way. So I multiply going at a diagonal, I add going vertically. So 9 minus 10 is negative 1. 5 times negative 1 is negative 5. 5 plus negative 5 is 0. 5 times 0 is 0. Negative 4 plus 0 is negative 4. 5 times negative 4 is negative 20. 20 plus negative 20 is 0. So those are my numbers. And what this tells me, if I get a 0 here, so this last number here is my remainder. So if my remainder was 0, then it must have divided evenly. So it wants me to write my answer in the following form. The quotient, which is this part that's left. So remember, these are all coefficients. In other words, they're the numbers in front of the x's. When I started with x to the fourth, I reduced down to where my first one now is x to the third. So I'm going to have a negative 2 x to the third minus 1, which I don't need to write the 1, x squared. There's no x because that's 0. And then minus 4. So I put the minus 2 is with the x to the third, the minus 1 is x squared, there's no x, and then minus 4, and then plus, and then the remainder, which is 0, would go there. So that's how they want their answer for that. Okay, 13 says, use the factor theorem to determine whether x plus 1 is a factor of p of x equals negative x to the third minus 4x squared plus 3. Okay, specifically evaluate p at the proper value. In other words, if p of x is negative x to the third minus 4x squared plus 3, then what they want me to do is evaluate what happens when I put the 0, right? X plus 1, so that would be a negative 1 is what goes in there. And if I put negative 1 in there, then let's see what I get. Now, incidentally, if you use this technique where you replace the x with an empty set of parentheses and then put the negative 1 in there, then it keeps the order of operations correct so that your negatives don't get all messed up and you don't end up with the wrong answer. Also, once you have it written like this, you can literally type it into your calculator this way. Negative parenthesis, negative 1 parenthesis, raised to the third power, minus 4 parenthesis, negative 1 parenthesis squared plus 3. And it's really helpful, I think. Of course, if you're using the ALEKS calculator, I'm not sure exactly how that types in compared to your personal calculator. But anyway, so I end up with a negative, so negative 1 to the third power is a negative 1, minus 4, negative 1 squared is a positive 1, plus 3, so negative times a negative is positive, minus 4 plus 3, so I get negative 3 plus 3 is 0, so I get a 0. So what did I do? I evaluated negative 1 and I got a 0, that's what you would put there. So is it a factor? And the answer is yes. If you get 0 as an answer, that means it's like saying the remainder was 0, so therefore it did divide evenly, so it is a factor. Okay, 14 says, for the polynomial below, 3 is a 0. And they want me to express f of x as a product of linear factors. So if they tell me 3 is a 0, then I don't have to figure it out. They've given me that 3 is a 0. So what I would do, if I'm trying to write it as a product of linear factors, then I already know that one of my factors is x minus 3, because x minus 3 would have given me 3 as a 0. But I need to find my other factors. So if I know 3 goes into it, what I could do is set up a synthetic division. I'm testing 3. I get 1, negative 9, 22, and negative 12. So I need to go ahead and pull this 3, or this x minus 3 out of here so I can see what's left. So I bring the 1 down. 3 times 1 is 3. Adding this, I get negative 6. 3 times negative 6 is negative 18. Adding those, I get 4. 3 times 4 is 12. Adding those, I get 0. Remember, this is the remainder. I knew I would get 0 as a remainder because they told me that 3 was a 0. So what's left is this. I started with x to the third, so that means this is 1x squared minus 6x plus 4. Now, I could just write that here, and it is true, but they want me to write this as a product of linear factors, and this is a quadratic. So I've got to factor this further, okay? And that's not gonna factor nicely, so I'll use my quadratic formula. So I'm gonna have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And let's see what I get when I do this. So negative 6 squared is positive 36 minus 16 is going to give me a 20. So this is a 6 plus or minus square root of 20 all over 2. And you can do that, take a couple more steps if you need to. I know I did it kind of quickly, but anyway, so what about the square root of 20? I can write the square root of 20 as the square root of 4 times 5, and the reason I'm going to do that is because then I recognize that 4 is a perfect square, so I could take it out. I'm going to erase this so that I can have room to write this. So the square root of 4 is 2, so I can write this as 6 plus or minus 2. What's left in the square root is the 5, and that's all over 2. Now, when can we reduce? We can reduce as long as you can take it out of all 3 of these items. I cannot reduce outside to inside of a radical. So if this had been a 2 in here, I would not have been able to reduce that. But I can reduce this outside, outside, outside. All 3 of them have to be able to reduce. So 2 goes into 2 once, 2 goes into 2 once, 2 goes into 6 3 times. So I get 3 plus or minus the square root of 5. And I know that's awkward and weird, but that really is the answer for my 2 zeros. I could write it out as this, 3 plus the square root of 5, 3 minus the square root of 5. Those are the other 2 zeros. Now, what did I do with my zeros? If you recall, you know, like they told me 3 was a 0, so I did x minus 3. So if these are zeros, I'm going to go x minus 3 plus the square root of 5, and then x minus 3 minus the square root of 5. And that is the answer. That's a lot of work. Question 15 says, find a polynomial f of x of degree 3 with real coefficients and the following zeros. So in this case, this is kind of similar. But notice that they give me one of the zeros is 2 plus 3i, so that's a complex 0. Something to know that's really important. If you have a complex 0, an imaginary 0, then you also have to have its conjugate. So in other words, if I have 2 plus 3i, I also have to have 2 minus 3i. And that will give me 3 zeros, which is good because I need degree 3. But it looks like they want me to multiply this out. They do not say I can leave it as the product of linear factors. So I'm going to start that way though. So f of x, my function would be x minus negative 2, that's 1 0, times x minus 2 plus 3i, that's a second 0, and then times x minus 2 minus 3i, that's my third 0. So if I could leave it as a product of linear factors, then I would basically be done. But they did not tell me I could, so I'm gonna actually have to multiply this out, and plus that way it'll show that it's degree 3. So the first thing I'm gonna do is clean this up a little. So this is x plus 2, this is x, I'm gonna distribute my negative, minus 2 minus 3i, and then distribute my negative, minus 2 plus 3i. Okay, and Now I need to multiply these. So I could either multiply these two first, get an answer, and then multiply it by that, or multiply these two first, get an answer, multiply it by that, or whatever. I'm going to show you a different technique of multiplying. You can choose to use it or not. I find that it's really nice if I'm doing like a 3 terms by 3 terms. So this is what I'm going to do. I'm going to multiply these two together. You could just do distributing if you want to, if you like that method better. I'll show you that in a minute. But if I wanted to multiply those 3, I would do it like this. X and a minus 2 minus 3i, so that's this guy. Then I would make a grid. And so the other one is x minus 2 and a positive 3i. And I would draw boxes here because that way it keeps my answers organized. So what you do is you start in a box and you look at what's to the left and what's above. So x times x is x squared. Here I would have x times negative 2, which is negative 2x. This would be x times negative 3i, so negative 3xi or ix, however you want to write it. Here I have negative 2 times x, so negative 2x. Negative 2 times negative 2 is 4. Negative 2 times negative 3i is 6i. 3i times x is 3ix, or 3xi. 3i times negative 2 is negative 6i. And 3i times negative 3i is negative 9i squared. I squared. Okay, but watch this, okay? I squared is negative 1. I squared is negative 1, right? I squared equals negative 1. So negative 9 times negative 1 will give me just a plain old positive 9. Okay? Now what's cool about the box is that if you look at the diagonals, you'll notice that they're basically like terms. Okay? So I've got an x squared, so that's right there. Then I've got a negative 2x and a negative 2x, which is minus 4x. So I've done this and this. Here I have a negative 3xi and a positive 3xi or ix, so those two cancel. Boom, boom. Negative 6i and positive 6i, those cancel. 4 plus 9 is 13. So these two ended up being x squared minus 4x plus 13. I have not yet done anything with x plus 2. So anyway, I like that technique. Use it if you want. You could use it on a 2 by 3 or 2 by 2 or whatever. I just wanted to kind of show you that that's an option. Okay, so in order to finish the problem, I still need to multiply this binomial by this trinomial. But this time I'm just going to do it using the distributive property. But there's a really nice way to do it where you can line up like terms. So here I have x times x squared, which is x to the third. And then I have x times negative 4x, which is minus 4x squared. And then x times 13, which is plus 13x. So I've distributed the x into the entire trinomial. So now I'm going to do the 2. So 2 times x squared is 2x squared. I'm going to put it here. I put a positive because it's a positive 2. I'm going to line it up underneath its like term. And here I've got 2 times negative 4x, which is negative 8x. And then 2 times 13, which is 26. And now I can just add that vertically. So I get x to the third minus 2x squared plus 5x plus 26 equals f of x. And now I have a degree 3 polynomial. Sorry about that. And it had those coefficients. So this is the answer to the question. And this concludes this video.